Our digital lives feel so clean, right? We just tap on a piece of glass and information zips across the entire globe. We stream movies, chat with our friends, and we store all our memories in this seemingly weightless cloud. But behind that sleek, cool interface is a very different reality, one of mines and power plants and, well, mountains of waste. So today, we're going to pull back that curtain and reveal the true weight of our digital world.
So it really all comes down to this one central question. Is our digital world truly weightless? I mean, think about the words we use. The cloud, the web, virtual reality. All of these terms suggest something that's immaterial. But as we're about to see, our digital existence has a very real and very heavy physical footprint.
And that footprint is getting bigger. Okay, let's start with this number, 1,000 terawatt hours. According to the International Energy Agency, that's how much electricity data centers are projected to consume every single year by 2026. Now, to put that into perspective, that is more electricity than the entire country of France used in 2022. It's a staggering number, and it's a powerful reminder that our data isn't magic. It's powered by an immense amount of real-world energy.
To really understand this, we have to look at the entire life cycle of our technology. So, let's start at the very, very beginning. The birth of the devices that we hold in our hands every single day.
That phone in your pocket, it didn't just appear in some sterile lab. It's this incredibly intricate assembly of materials that have been sourced from all over the world. It's less of a single product and more like a miniature United Nations of minerals, all dug out of the earth.
And you can see just how much that complexity has exploded over time. A telephone from back in 1960 used about 10 elements from the periodic table. Simple enough. By 1990, that number jumped to 27, and a modern smartphone today, it contains as many as 63 different elements. Every new feature, every boost in performance requires a more complex and diverse recipe of materials. And getting all 63 of those elements, well, it comes at a steep environmental price. Mining is incredibly energy intensive. It's responsible for a huge chunk of our greenhouse gas emissions. It's also really thirsty work. Making just 1 ton of lithium can use nearly 2 million liters of water. And that's not even mentioning the pollution and deforestation that so often come along with it.
This all points to a key finding from the UNCTD Digital Economy Report. It highlights what's called an unequal ecological exchange. What that basically means is that developing countries often have to bear the heavy environmental and social costs of digging up these minerals, while the economic benefits and, the final products flow primarily to developed nations.
Okay, so now let's move from the physical device to the invisible infrastructure that gives it life. This is where we get into the power consumption of our data itself.
Now, what's really important to get is that not all digital tech has the same kind of footprint. For your smartphone, something like 80% of its lifetime carbon impact comes from its production, all that mining and manufacturing we just talked about. But for a data center, the biggest impact by far comes during its use phase, from the massive amounts of electricity and water it just consumes 24/7.
And some digital activities are way, way more intensive than others. Take Bitcoin mining. In 2023, its global network consumed an estimated 120 terawatt hours of electricity. That's all thanks to its proof-of-work system, which basically has computers all over the world competing to solve these complex puzzles, just burning enormous amounts of energy in the process.
But, and this is really important, it doesn't have to be this way. The Ethereum cryptocurrency used a pretty similar system until 2022, when it switched to a new model called proof of stake. And the result? It cut its energy consumption by an estimated 99.95%. It's just a powerful example that the design choices we make in our technology can have absolutely dramatic environmental consequences.
So we've covered the birth of our devices and their life in use. But what happens at the end of that life? Well, that brings us to the third and final stage, the afterlife of our gadgets.
A key driver of our e-waste problem is this concept called programmed obsolescence. It's the idea that products are intentionally designed to become outdated or just stop working after a certain period, which of course forces us to buy new ones. This can happen through software updates that slow everything down or by simply making the devices really difficult and expensive to repair.
And this isn't just some theory. The UNCTAD report highlights the famous Batterygate case, where Apple agreed to a massive settlement over charges that it intentionally slowed down older iPhones through software updates. It's a textbook example of how a company's decisions can directly contribute to making a perfectly functional device feel obsolete. And the result of all of this? A mountain of waste. In 2022 alone, the world generated 10.5 million tons of e-waste just from screens, computers, and small IT equipment.
That is the weight of almost 100 aircraft carriers every single year.
But what happens to all that waste? First, that term on the slide, SCSIT. That just stands for screens, computers, and small IT equipment. And you might assume most of it gets recycled, but the reality is staggering. Globally, a massive 75% of this e-waste is improperly disposed of. It just ends up in landfills or informal dumps, leaching toxic materials into the environment and wasting all those valuable elements we worked so hard to mine in the first place.
Now, I know this all sounds pretty bleak, but it is not the end of the story. Let's pivot from the problem to the solutions and explore a new way of thinking about our digital world, building a circular digital future. A circular economy breaks that old linear model of take, make, waste. Instead, it prioritizes keeping resources in use for as long as possible. And the hierarchy here is key. First, you reduce consumption. Then, you reuse and refurbish existing devices. And only as a last resort do you recycle their components to make new products. It's all about turning waste back into a resource.
This all leads to an ultimate goal, what the UNCTAD report calls digital sufficiency. It's a huge mindset shift. Instead of chasing the newest gadget and maximizing our use, it means using technology mindfully and frugally, enough to meet our needs and support sustainable lifestyles, but not more.
And one of the most powerful policy tools to get us there is the right to repair movement. This is all about fighting programmed obsolescence head-on by demanding that companies make their products repairable. It empowers us, the consumers, to fix our own stuff, which keeps devices out of landfills and reduces the demand for new mining.
Which brings us right back to the beginning. The digital world is not weightless, and its physical costs are immense. But as we've seen, from more efficient cryptocurrencies to the right to repair, we have pathways to a better future. The final question really isn't whether we can, but how we choose to build a digital world that is both incredibly connected and truly sustainable.